Hello everybody, this is Dr. Christopher White, and in this presentation we're going to continue thinking about volcanoes and volcanic hazards. So the next topic we're going to think about are basaltic volcanoes and what types of characteristics we tend to find associated with them. So when we talk about basaltic volcanoes, what we're talking about are volcanoes which are going to erupt a mafic lava, and that mafic lava will typically cool to give us the mafic volcanic rock, which we term basalt. So here we have ourselves a basaltic volcano, so a mafic volcano. We can see here's our vent from which the lava is exiting onto the surface of the earth, and we can see that we have ourselves a lava fountain right there. And if you remember, that's being produced by gases exiting the lava, and that volume expansion is pushing the lava out of the vent and throwing it into the air, a bit like popping the cork on a bottle of champagne. You will also notice though that we have the lava exiting the crater and leaving in the form of a flow. So this is a relatively gas poor layer of material which, instead of being thrown up into the air, is just simply flowing away like water. And we know that basaltic or mafic lavas can do this because they have a very low viscosity, so they can flow over very, very large distances. And so this means associated with basaltic eruptions, we can end up with two main classes of rock. We get very, very vesicular rocks forming during this lava fountain portion of the eruption. And we have rocks which are either vesicle free or relatively low in the number of vesicles they have, which are associated with lava flows. So that's essentially the lava flowing across the surface. So here you can see we have a rock which we refer to as a vesicular basalt. So this is a piece of basalt, and as you can see, it's full of these vesicles, giving it this Swiss cheese-like appearance. So where is this rock going to be forming? Well, this rock is going to be forming as part of the lava flow. So what we have is a situation where we have a lava exiting the crater, and within this lava we do have some gas bubbles, and these gas bubbles don't have enough time to escape before the lava flow solidifies and traps them. In some instances though, we have a non-vesicular basalt. This is also formed as part of the lava flow. And this is formed when the gases which are exiting the lava have essentially had the opportunity to escape the lava flow, and so this results in the lava cooling down and producing this nice uniform vesicle-free basalt. Now, the final type of mafic extrusive igneous rock which can form is something which we refer to as scoria, and you'll notice this is highly vesicular, so it contains lots and lots of these vesicles. That means there were loads of gas bubbles being formed as this particular lava was being erupted, and so the scoria is actually forming as part of this eruption right here. So because we have all of this gas exiting the lava very, very quickly, we get lots and lots of vesicles, but the gas bubbles get trapped quite quickly, and that's because the gas that leaves the lava takes a lot of heat with it. And so this means this lava over here is cooling down very, very quickly because it's losing heat to the gas bubbles that are forming. And so that means this lava is going to solidify, so it's going to harden up very, very fast, and the gas bubbles are going to get trapped inside it. And so this is going to produce this very, very highly vesicular rock, which we call scoria. And scoria will typically form chunks of rock, which will be anywhere in size from maybe a few millimeters to an average size would probably be about the same size as your fist. And that's because we have these blobs of lava which are getting thrown up into the air. You can see them here along the edge of the lava fountain, and these blobs of lava are full of gas bubbles. They're cooling very, very quickly, so the gas bubbles have very little time to escape. And so that means these pieces of rock, these pieces of lava get thrown up into the air, they cool and solidify, forming scoria, and then those pieces of scoria just fall down around the vent, and that leads to the formation of a scoria cone, or sometimes referred to as a cinder cone volcano. So here's the classic model for our scoria cone volcano. Here's our central vent through which the lava will be exiting, and during the early stages of the eruption this lava will tend to be quite rich in gas, and so that's going to lead to the formation of a lava fountain like this one here. That's going to throw lava into the air where it's going to cool down and solidify. That lava is going to be full of vesicles, and so it's going to end up giving us scoria. And this scoria is going to pile up around the sides of our volcanic vent, and it's going to form our scoria cone volcano. So that means the flanks of this volcano are actually going to be quite weak, because they're going to consist essentially of a pile of material. And so that means that scoria cones, as you can see, here's an example of one right here, are actually going to be quite easy to erode. And so you can actually break them down relatively quickly. Now, what will tend to happen is as the volcanic eruption finishes its early stages, it will have lost most of its gas. And at this point, the style of eruption is going to change from a lava fountain style to volcanic flows. So we're actually just going to have lava flows coming out of our volcano. Now, in the case of scoria cone volcanoes, the lava doesn't exit via the crater. Instead, because the sides of our volcano are so weak, because they're just made of this mixture of different sized pieces of scoria, it means the lava can actually just push its way through the flanks of the volcano and extrude out from the bottom of the volcano. And so you would end up with something that looks like this. You would get the lava flow itself has all these pieces of scoria, this very rugged, very uneven looking material on the top. That's material that's fallen off the side of the volcano as it's been pushed, as the lava flow is pushed out, and underneath this layer you're going to have the lava flow itself. And so we can see that the scoria cones are the result of essentially two different phases of eruption. We have the earlier, more gas-rich portion. That's going to produce lots of highly vesicular basaltic rock, which we see in the form of scoria, and that's going to pile up around the vent, giving us our scoria cone volcano. And then later on, as the volcanic eruption begins to slow down and become a bit more gentle, we're going to get a transition to lava flows. And these lava flows are going to actually exit the volcano typically by bursting out along the lower edge of the volcano, because it's just easier. Rather than wasting your time and trying to, being erupted out of the crater, you can just push your way through the side of the volcano and be extruded onto the surface of the Earth via that route instead. Okay, that's it everybody, and thank you for watching.